just want to say thank you for joining our session today. It's going to be covering identifying and mitigating bias in AI models for recruiting. My name is Jason Safely. I'm the CTO for Opley. I've been at Opley for about 2.5 years, been in IT, product, analytics, and data science for well over 20 years. 10 of that, or a better part of a decade, has been within the human capital industry. So I look forward to reviewing this information with you. Katie, did you want to introduce yourself?
Sure. So my name is Katie Bakewell. I'm the VP of AI Strategy at NLP Logics. I've been here for a little over 11 years, and in that time built machine learning models across multiple industries, but one of my favorites is the human capital space.
All right. Thanks, Katie. The first thing I want to do is just provide a little bit of context relative to who Opley is, why we built what we built. Opley was formed and founded back in 2017, and our primary mission, really around the development of our technology and innovation, has been to remove the friction between talent and work. And we have applied multiple data science practices. We've developed multiple apps, which I'll cover in a subsequent slide, but it's all centered around how do we align individuals to work and how do we remove some of those friction points relative to that. Some additional overview of the products that we've developed. Back in 2017, we made a strategic decision to develop our proprietary large language model. That large language model was developed, it was trained, it was tested based on the world of work and data specific to that. The reason that we did that is because we wanted to guarantee the output of our large language models, aligned to our industry itself. So it's important for our model to understand context, especially as it relates to the data that it's going to be interpreting. So very different. Python within nature is very different than Python for a software developer. So context is very important. So the outcomes of our large language model is really a deep understanding of its ability to interpret a job description relative to the skills that are part of it, and also the resumes that it's analyzing to determine the synergy between the two and removing that friction point for our recruiters. On top of our LLM, we built some really persona-driven applications to enable some personas within our industry. First is the candidate experience. The candidate experience that we've developed empowers our end users to be able to analyze opportunities that are aligned to their skill set. So if you think about it out in the world of work today, job boards, you traditionally have to skim through jobs that have no relevancy. But using our LLM, we're able to offer out relevant opportunities. So they have a deep understanding that if they apply for those roles, they're going to be a good fit for those roles as well. The same approach is for the apply application that we've developed. Applicants, although unknown to our LLM when they apply, still get a contextual understanding of the skills that are required for that job because we surface it through our front end. And then the most significant application that we've developed over the past year is Opley Curate. And this is really to empower the recruiter. With the introduction of jobs from various sources, a recruiter can quickly analyze the skills of a job, then also request matches from a candidate perspective based on the skills that it injects into a talent community. So it just enhances the overall experience for the recruiter, whereas they traditionally have had to write Boolean strings. They've traditionally had to search for things based on job title. Then the final offering that we built most recently is our skills intelligence platform. So these are skills-based products that address different friction points within our industry. More times than not, what we find is within organizations, they're struggling with their job taxonomy. Their jobs are all over the place, and they don't have an automated way to rationalize those. So we built a front-end application to leverage our LLM to help them accelerate that process, whereas is traditionally would take analysts many, many hours to actually get to a final result. Other places that we've thrown our LLM at, we can generate job descriptions based on the output of our predictive model. We also have a tool called the Workforce Skills Inventory, so where the LLM does a really good job with evaluating jobs. It also does the same for a workforce. So as organizations try to move towards a skills-based organization, this front-end application allows the end user to introduce a workforce and understand the skills gaps or the skills concentrations relative to their workforce. Some additional context before we get into the technical details of the LLM is really strategically, what does AI provide within talent evaluation and really talent acquisition? I've touched on the skills-based talent evaluation briefly, but the evolution of our industry is going beyond just looking for those individuals that have worked in roles Using our LLM, what you're actually able to do is actually able to identify the skills composition of the job that you're looking for and inject that into a talent community to surface up those individuals that are a right fit based on their skills. What that allows the end user to do is, instead of just pulling back those individuals that match the job title, it actually finds those right fit candidates that have the right skills composition to do the job. Some other strategic benefits relative to leveraging AI in our space is the scalability and the acceleration. So there's a war on talent that's been going on for quite a while. But leveraging AI, what you can do is you can identify that talent much quicker than a human could possibly do that through the vectorization of the jobs, through the vectorizations of the candidates. You can quickly surface up a substantial number of candidates within seconds. In addition to acceleration, accuracy and objectivity is really important, and we'll touch on this as we're talking through bias. But the AI is purposely trained just to focus on the skills. It's trained to omit race, gender, age, any protected class attributes in its evaluation of person. So what that means is you're minimizing, you're mitigating some of that human bias that traditionally would happen in the upfront process with recruiters searching out for talent in traditional means. The final two things, the workforce planning enablement, that's really where we lean into that skills intelligence offering that I notated in the previous slide, being able to use front-end tools to truly understand the skills that you need from a demand perspective, and then the skills that are available from a workforce perspective, allow organizations to plan and address any skills gaps that they have. And actually, it assists in any conversations relative to internal mobility or succession planning as well. And then the final advantage from an AI perspective, and I'm sure there's many more, is really just the adaptability of the AI. So through the introduction of fresh data, through the introduction of data that changes so often with our industry, the AI can quickly identify any additional skills that are entering the market or becoming more important within the confines of roles. And this can happen much quicker than any human can possibly do that. And it's so scalable that instead of having to train multiple individuals to identify and use these skills, the AI automatically uses the new skills and the new importance that it's learned. Katie, I'll turn that over to you.
All right, so we'll first talk about how we built the underlying model. So the underlying model started with 12 million resumes and job descriptions. So we pulled data for 12 million resumes and then cleaned and parsed that data. So going through, getting it all into a database structure, and then using NLTK to go ahead and get that clean, take out anything like stop words and really, just replacing data where we can to make sure that we have the cleanest possible set of data. And then we use GenSum and NLTK to fit a Word-to-Vec model using those 12 million text strings. And those text strings are representative of the job task details within a resume. So not using things like the person's name, but just what are they doing and what is their objective, taking that and fitting that into a model. And then we did build supplementary use cases as well, and we'll get into those in a little bit more detail. But we did those using NLTK and sklearn. So overall, the inference process here, when a new match list comes in, when there is a brand new job and we want to figure out who are the right people for this job, who are the people that we want to surface, that we want to send out a campaign to, we're going to start out with our full candidate pool. So we're talking about 12 million plus resumes here. And we want to be able to identify, how do we find 500 people? How do we find the best 500 people? If I'm looking for a nurse, I don't need to search through teachers' resumes. I don't need to look at software developer resumes. So we go through a first pass where we filter down based on title similarity. So we have a title taxonomy, and we filter down to what we call a talent community. So a talent community is going to be about 100,000 potential employees that are the ideal, title makeup. And then we go through and use cosine similarity for the job description versus those 100,000 candidates to identify what are the best 500 within that talent community. Who are the people that really have, a complete match from their job description to their job or to their resume. So once we have that, we go through this final piece. So as Jason said, a lot of this is really skill driven. So we take the skills that are necessary for the job, and then we look at a candidate's resume and look at the skills that they have that are also related to that job title to give us a prioritized list of prospects. So what that does is twofold. It first of all lets us have that priority list where we see that these people at the top are really a great fit, but it also lets us mitigate things like a candidate going and writing a 2-page resume where one page is really just a list of their skills. It's actually going to penalize a candidate for doing something like that. We want to see that these are candidates that have the skills and they've actually used those in a job. So we go through this process where we're going from 12 million people down to 500 with a working list that a recruiter or a curator can use to make their actual campaign. So when that curator or recruiter takes a look at the candidate, what they're seeing is the output that's on the right-hand side. They're seeing a profile about the candidate. They're seeing a score. We use dots or, a raw number where they're able to see, just is this person a good fit? They see their resume as a blob of text, and then they see that skill analysis down below. It tells them what skills were a good match, what skills were we able to infer using AI, and what skills maybe they're missing, what skills are needed for this job that this candidate doesn't have. So the recruiter sees exactly what they need. But then on the left-hand side, you also see what information do we pull? What do we store when we have this candidate? So we have, the obvious IDs, and then we have the score, which is that cosine similarity. We have a rank for that overall list rank. We have an adjusted score, which is that skill-based score, that final score that we're taking a look at and the rank based on that. And then we also have things that we use for model health where we're measuring our statistics afterwards. So we're looking at the match list the way that a candidate or a curator would also look at the match list. Do they have the right title? Do they have the right skills? And have they actually used those skills? So that gives us an overall model score that we're not using for the curator, but we're actually using for tracking our model health after the match list has been completed. So we have this robust set of metrics that we track, but what the recruiter is seeing is just the information that they need to see. So we also have a couple alternate outcomes that we get. We want to extract the most value from those embeddings. We want to have our custom taxonomy. And I think these are really, really important to the success of the model. The first one being anchor title. So, in the case of using something like a vector store, you'd have an ANN cluster that's going to tell you these are the closest people. What we're actually able to do is do that based on those titles. We're able to say that these are the titles that are the most similar to a job because we've built out this taxonomy. We did in the beginning look at some existing taxonomy. So you have things like ONET, which are going to be a little bit too broad. You're going to have us all software developers falling into the same place. And then if you go and you look at a candidate's raw job title, most of the time they're great. People use good job titles. You also get people who call themselves code ninjas. And, a code ninja is not really a job title that our model knows what to do with. So we have this custom taxonomy that we've built with these anchor titles. So those are the about 2,000 titles that we keep in our taxonomy, and then similarity amongst those so that we're really able to go in and see, these are the titles and these are the ones that are similar to it. So if I'm looking for a Java developer, I might also be willing to take a Java front-end developer. Similarly, we use TF-IDF and a combination of those embeddings to build out a skills taxonomy that lets us see not only for an overall candidate, what are the skills, but specific to a job, specific to a specific title, what are the skills for this candidate? What are the skills for that actual job? So that lets us have a really robust view of skills that we wouldn't otherwise be able to have. So resume parsing is a really, really important piece of this because at the end of the day, the candidate isn't providing us the data in the form that we need. They're providing us a resume. So if we look at Christina Simmons over on the left, if I have an off-the-shelf parser, I have an ideal scenario where I get only the overview, the work history, title, the descriptions, and the skill list. I don't want to know about a candidate's image. I definitely don't want the demographics or the identifiers. We don't necessarily need company names or educational institutes. We just need to know, what does this person do and what would they like to do? So we have just that information that comes through. But resume parsers aren't perfect. So a lot of the time, we will see things that sneak in. So something like a first name might sneak into the resume, or, you might have a reference name within a job description, and that'll pull that information in. So resume parsers do occasionally miss pieces of information, and we want to make sure that we, understand that and are able to mitigate against cases where, a candidate who might not necessarily see that name, or a curator who might not necessarily see that name, is seeing that additional information. So, we were at a conference about a year and a half ago, and David Talby took the stage and started talking about this process where a model could be trained and then tests could be generated. And those tests for these language models included things like bias, robustness, accuracy, fairness. And then you could run those tests against a suite of models. So it could be any of the models that you see on that list below, or the custom models like we do in the case for Opley. And then you could decide, this is a model I'm ready to release, or this is a model that's seeing issues due to bias, due to robustness, and then maybe augment that data and then be able to retrain. And as we're hearing this library that's an open source library that has the ability to do this testing for bias, the first thing that comes to mind is, oh my God, we have to use this for Opley. It's incredible. It's really the suite, and for it to be open source, we were just amazed. So we started testing out what that would look like within the Opley environment. And where we ended up is being able to create these synthetic cases where we can test. We can say, what if we change demographic information within this resume? Is that going to change the actual output? So the test categories that we use here, we've got about 15 that we use. So country names, we're looking at anywhere where we see a country replacing high-income countries with low and middle-income countries. We're looking at replacing pronouns, so he's replaced with she's or they's, and replacing first and last names. So we might take a first name traditionally associated with a Caucasian last name, and then be able to replace that with a Hindu last name, or a Sikh last name, or a Muslim last name. And that's going to let us be able to sort of simulate what happens with these different ethnicities. And then from a robustness standpoint, and even, when I look at specifically our use case, goes beyond robustness and into bias, we're also able to replace British English with American English and vice versa. That can be really indicative of national origin. So that lets us really have an additional case that is, something that's important to know. So we're able to take those synthetic data and look at the original resume and then this synthetically generated resume and compare what would have been the outcome. Is the likelihood that this person would get a job that would show up in this match list, is it going to change based on that information? So the first thing that we have to be aware of is that there's room for error. So all of that replacement is based on a named entity recognizer. So NER models are amazing. And, the one that we suggest is the Encore Web transformer through the pipeline. But when we take a look at that, if you use the small one, you're going to have some really, really funny results. But it can be any named entity recognizer. We're going through, we're doing this NER, and then we're going and replacing things. And sometimes erroneous replacements happen. Sometimes they're innocuous. I love the example on the left. So May fabricate and modify parts. May is a first name, and it got replaced with Donald. So Donald also fabricate and modify parts. It's not really that big of a deal. May is not a specific skill. It's just a verb that's contained within the sentence. So it's not causing huge issues. We do have some cases with troublesome replacements. And I'm using this example. This one was actually from using the Encore Web Small. But I think, if you use the transformer, you do still occasionally get these that sneak through. But we had a resume for a person that used Power BI as a skill. And if you change Power BI to Power Read, that is actually going to change your likelihood of getting the job. When you're looking for a Power BI visualization job and you change it to Power Read, that does drop that score pretty significantly. So what that let us do is establish a baseline and an understanding for where we were comfortable. So we apply LangTest in 2 stages of the model lifecycle. So we do it in training. Anytime that we're going to release new code, we can test this on our gold label set for bias. So we can go back and say, is there any bias in what we're seeing in that training model? And technically, we're not updating the model. I'm confident that our model doesn't have that bias in it. But because we're using an off-the-shelf parser And because the way people write resumes changes over time, if you've seen resumes recently, they don't look like what they did 10 years ago. The way that people format things, just it's a little bit different, and people use, different stylistic things. So what we do is randomly sample a candidate in every single job that we build a match list for. So every time we build a match list, we're sampling so that we can test it in inference as well as in training. So in training, that first initial piece, we've got our 200 randomly sampled job and candidate pairs. These are candidates that were historically great matches to a job. So random top 100 candidate. That leads us to 1,600 resume job pairs where there was at least one thing that needed to be replaced. There's a lot of cases where nothing needs to be replaced, but there were 1,600 where there were 14 potential conflicts, and those were all manually reviewed. So those are places where there was a difference between the cosine similarities there, and we had 0 resulting issues. But that let us look at, we had an overall tolerance of about 0.2% for individual cases, or an overall tolerance of about 1% for job by job seeing any difference. And what we also look at is, again, looking at that month on month. So we can track for every month that we're doing, match listing. What are we seeing as that error? We have that black line, which is representative of that 1%. For each individual job, we're willing to see 1% of jobs where there is an issue. And we do, I'd love to say that we don't manually review them, but we do actually go through and manually review because, I want to make sure that nothing we're doing has bias. But we do still have, that we've never gone above that threshold that we set. But we review these monthly during a service review. It's really important for our team, just taking pride in the model that we are seeing that the model continues to be unbiased, but it's also really important for Oply and for their customers. And I think Jason's going to dive into a little bit of why this is so important within their space.
Yeah, so like Katie said, what we have to do is we really, from an AI perspective and really from a hiring perspective, we have to navigate some of these risks, with unaddressed bias. And that's really why we take a proactive approach to our testing of our large language model. So we're probably all aware there's various laws against bias just within the recruiting space outside of the AI legislation that's been introduced. But over the past few years, there have been specific AI legislations around the use of AI and their evaluation of talent within our space. So a lot of that legislations around, are you conducting audits? Are you disclosing that you're using AI to evaluate talent? Are you being transparent with your processes, and are they defensible on how you're surfacing the outcomes? So that's really why we take that proactive approach. By not doing so, we put ourselves in a bad place relative to penalties and fines. And that's really why we have this approach. That's why we're very proactive in testing, ensuring the outcomes are exactly what are expected of our model. There's some other risks there relative to using a biased AI model. Talent blind spot. You may be missing talent based on the narrow profile that you're training your large language model on. That has impacts on the fact that you may not be identifying top talent within the industry to pull in. And it may limit your innovation and creativity within your organization because of that tunnel vision relative to the people that your AI model is identifying. And then finally, the reputational impacts, right? So you potentially, if this gets out in the market that you are using some level of a biased AI or even a biased hiring practice, your potential to lose potential candidates increases. And then you have the potential to kind of erode your existing workforce if they learn the same. So there's a lot to mitigate. There's a lot to navigate in leveraging a solution, specifically AI and its evaluation of jobs and talent. So the one thing that we did also, we developed a partnership with Pacific AI, and we're using their Pacific AI framework really to solidify our stance on responsible AI. And part of that, and this aligns very much to like the SOC process or the ISO process. So if you're familiar with that, this is very similar to that. And I think this is the right way to go in evaluating our AI. So the governance component, making sure you have the right policies and procedures in place, taking a proactive approach and tracking legislation that's entering our market, risk management, and also transparency on what we're doing, and transparency on how we're testing and how we're evaluating the unbiased nature of our AI model. Testing, I believe Katie touched on that quite well, but part of that is also, what is our release process? What's our versioning process? We need to provide transparency into how we are iterating, how we're rolling out models into our production environment. And then the monitoring piece that Katie touched on as well. How are we measuring bias in production? How are we measuring the drift of our model through the refinement and the training of our model and the introduction of additional data into our environment? And then that feedback and explainability, and Katie touched on that as well, is if we do find something, what does that trigger from a retrain or an evaluation or an analysis? And then ultimately, Pacific AI, what they enable for us is a third-party view, a third-party audit of the controls that we put in place here, ensuring that our use and our development of our AI meet those requirements. And I believe we're seeing a lot of that from a requirement perspective in legislation, which makes this framework, makes us adhering to this framework that much more important. And then the final piece of this, there's always room for roadmap for additional development. A lot of this is really around providing additional transparency for different personas that would use this information. So companies and recruiters need readable, non-technical domain experts. Employees and candidates need a level of transparency about how their information is being used, how they're monitoring results. And then finally, obviously, the regulators in the industry, although we haven't seen an overarching AI legislation body relative to our space, I think it's coming. I think very similar to SOC and ISO, I think that's coming down the path as well. So taking a very proactive approach in our development will make sure that we stay in alignment with how the market is changing relative to responsible AI. And that's it. I just want to thank everybody for, on behalf of Katie, I want to thank everybody for joining our session about identifying and mitigating bias in AI models for recruiting. So thanks.